Engine run-up in reciprocating engine operation. As an aviation maintenance technician, you must be thoroughly familiar with the procedures for operating a reciprocating engine from the cockpit. This includes understanding the engine instrumentation, ground run procedures, and safety items associated with starting, running, and stopping an aircraft engine. A good place to begin with is with the location and movement of the engine controls. The three primary controls for reciprocating engines are the throttle, propeller, and mixture. The engine controls on most modern aircrafts use standardized shapes and colors. Ground operations. Operating an aircraft engine on the ground is a necessary part of an inspection because this activity prevents a safety hazard to personnel and surrounding equipment. You must take certain precautions and conduct engine run-ups in an area specifically designated for that purpose. Ensure that the run-up area is level with a clear surface and position the airplane into the wind and in such a way as to avoid blowing dirt into a hangar or onto other aircraft. For powerful aircraft, you should chuck the wheels securely or tie the aircraft down to prevent movement during engine power checks.
Engine starting. Operating an aircraft engine on the ground requires following specialized procedures and general safety practices. Each type of engine and aircraft installation is unique, so be sure to study the procedures in the appropriate aircraft flight manual and seek instruction from an experienced operator. However, certain general guidelines apply to starting all reciprocating engine aircraft. Before every engine start, unmoor the aircraft, check engine fluids, and verify that cockpit engine controls are intact and operational. In addition, carry out the engine run-up in a safe area with fire extinguishing equipment and appropriate personnel. Power check. Most aircraft manufacturers require to operate the engine at full power during the ground check. The power check measures an engine performance against the manufacturer's established standard. Any given propeller operating at a constant air density in a specific blade angle requires the same horsepower to turn at a certain speed.
Engine warm-up. Operate the engine at a speed between 800 rpm and 1000 rpm until normal operating temperatures are attained. At lower speeds, leave the mixture control at the recommended setting. Avoid using a lean mixture to hasten engine warm-up. Proper engine warm-up is important, particularly when the condition of the engine is unknown. An improperly adjusted idle mixture, intermittently firing spark plugs, or improperly adjusted valves all have an overlapping effect on engine stability. Maintenance. Engine reliability is paramount for safe aircraft operations. To maintain reliability, you must perform the appropriate engine inspection and maintenance according to the manufacturer's schedule. Airworthiness standards are related to the design, construction, maintenance, and overhaul of aircraft engines are contained in 14 CFR 33. Airworthiness standards aircraft engines of this part requires that engine manufacturers provide instruction for continued airworthiness for each type of engine they produce. Instruction for continued airworthiness include airworthiness maintenance manual, operating instruction, inspection items, and intervals, overhaul procedures, and airworthiness limitation. Engine maintenance tasks and overhaul operations are established by the manufacturer and are scheduled at intervals based on calendar time.
Engine run-up. Turbine engine operation. An aviation maintenance technician should be thoroughly familiar with the procedures necessary to operate a gas turbine engine. This includes understanding the engine instrumentation, ground run procedures and safety items associated with starting and running a turbine aircraft engine. For any aircraft that you are required to run, first familiarize yourself with the location and movement of the engine controls. In addition to the engine controls located at all of the engine instrument, be sure to read all placards and other markings on or near the instruments. The engine instruments display important engine operating information that you must monitor during an engine run. It is critical that you are able to interpret instrument readings and avoid engine damage during the operation. Ground operations. As a maintenance technician, you will often operate a gas turbine engine. For example, troubleshooting a discrepancy reported by the flight crew might require you to operate the engine to attempt to duplicate and analyze the fault. You will operate the engine to test its performance because and after from the turbine inlet before starting. Be sure that all ground support equipment such as auxiliary power charts, hydraulic service units, and fire extinguishers is positioned a safe distance from the aircraft. Observe all warnings to keep people safely outside the turbine intake and exhaust danger arcs when the engine is running. Inspect the condition of the compressor and turbine and verify freedom to motion. Additionally, check the operation of communication equipment between the cockpit and ground safety personnel.
Engine starting. Upon entering the cockpit, verify that the master switch is off, the landing gear handle is in the down position, and the generator switches are off. Additionally, check to make sure the power level are in the cut-off or fuel shut-off position. And the starter, the ignition switches are off. If using a ground power unit to start the engine, verify that the correct voltage is being supplied to the aircraft. When ground personnel indicate that conditions are safe for engine start, turn the master switch and battery or external power switch turn on the fuel boost pump. Maintenance. Because of the hundred of different gas turbine engine model in use today, it is impractical to list and explain the various maintenance procedure for all of them. Instead, you must consult each specific engine maintenance manual. Engine manufacturer and responsible for providing maintenance and overall information in the instruction for continue airworthiness section in the maintenance manual that they produce. In additional, federal aviation regulation required that each set of maintenance manuals provide details service.
An airplane's power plant includes the engine, propeller, and engine accessories. Not only does it provide thrust, allowing the airplane to accelerate and climb without assistance, but it also powers the various aircraft systems by providing electrical power and driving fuel, air, and often hydraulic pumps. At the heart of the power plant is the reciprocating engine, which produces power by burning gasoline inside its cylinders. This causes the back and forth or reciprocating movement of a piston inside each cylinder. Each piston is connected to a rod which translates this back and forth motion into the spinning of the engine's crankshaft. The engine operates on a 4-stroke cycle. The first is intake. An intake valve opens, allowing a highly flammable mixture of vaporized fuel and air to rush into the cylinder. When the cylinder is filled, the intake valve closes. Next is compression. As the piston is driven upward by the motion of the rest of the engine, it tightly squeezes the flammable mixture into a small space near the top of the cylinder. Third is the ignition or power stroke. A carefully timed firing of the spark plug ignites the fuel-air mixture, resulting in a great deal of heat and pressure inside the cylinder, which powerfully forces the piston downward. The exhaust stroke finishes the cycle by allowing spent exhaust gases to escape through the exhaust valve as the piston rides to the top of the cylinder once again. When the piston reaches the top of the cylinder, the exhaust valve closes and the cycle starts over. The intake and exhaust valves are held closed by springs and opened by a camshaft. As the engine turns, it drives the camshaft, which is shaped with strategically placed lobes along its length. These lobes open the intake and exhaust valves on the different cylinders as the camshaft rotates. Reciprocating engines are described by the number and arrangement of their cylinders. Common cylinder arrangements are radial, inline, V-type, and opposed. Opposed engines are the most common on small airplanes since they produce good power pound for pound without creating a large amount of drag as the airplane flies. In contrast to automobiles, airplane engines are air-cooled by outside air, which is routed by baffles across the cylinders and engine. Each cylinder has fins which allow the air to cool the cylinder more effectively. When an engine is air-cooled, a combination of high engine power and low airflow tends to cause the engine to run hotter. This situation is typically encountered during climb-out. The engine temperature gauge should be scanned to ensure the engine's temperature limitations are not exceeded. Excessively high engine temperature will cause a loss of power, excessive oil consumption, and possible permanent internal damage. Operating an engine at a higher temperature than it was designed for will cause loss of power, excessive oil consumption, and detonation. Detonation occurs when the fuel explodes suddenly inside the cylinder instead of burning evenly as designed. This sudden detonation of the fuel is often described as engine knocking. Engine pre-ignition occurs when the fuel spontaneously ignites inside the engine prior to the proper time for normal ignition. Pre-ignition can be caused by hot spots inside the engine or by an overheating spark plug. It changes the timing of the engine and is also often referred to as engine knocking. To prevent detonation, the pilot should keep the temperature of the engine within the recommended limitations. Lowering the nose will allow the airplane to gain speed, which will eventually lower the engine temperature.